Again, welcome to another dynamics video. We're going to sort of move on and start to get a little bit more complicated now by solving this problem, and then there's a few at the end that you can have a crack at yourself. So the scenario here, we've got a Formula 1 racing car driver, reaches a speed of 60 kilometers an hour after travelling a distance of 100 meters. He's applied a force to make that happen, and we're going to look at his acceleration and how long that actually takes. Okay, so first thing we're going to do is going to take the known values out of the question. First known value we've got is this 60 kilometers an hour here. Okay, so we're looking for this word here, speed. Another word for speed is velocity. So velocity is equal to 60 kilometers per hour. Okay, don't know what that line's there, but anyway. Now, the more observant amongst you will realise that that 60 isn't in the right units, so we need to divide that by 3.6. And there is a reason for that, and if you forgot the reason for it, go back and check previous videos about converting units, in particular kilometres an hour to metres per second. So I'll let you pop that into your calculator, and we'll get an answer of 16.6 metres per second. Okay, next thing we're going to do, we'll look at our next bit of information after travelling a distance of 100 metres. So the distance, and it's represented by the letter S, is equal to 100 metres. Last bit of data we've got in here. This speed he's been required to apply a force of 6,000 newtons to make the wheel spin. So I'm going to pop that down there. Force is equal to 6,000 newtons. Now I might not need all this information. I certainly don't need all this information for the answer the first part of the question, but it's a good strategy to start to lay this out. So let's have a little look at the formulas we're going to need. Now if you check out your formula sheets, which you've got and you'll be given during any assessments, you'll see the equations for linear motion, and there's 4 of them. Now from those 4 we can calculate lots of unknown values. So what we're looking at is we're looking at what information we've got and what information we need. Now, first formula we've got on here, V equals U plus AT. Now, if you have a look at our list, we don't have T. So anything with a T, we can't use at this stage. So we're only left with one formula, and that formula is V squared equals U squared plus 2AS. Now, you'll be saying to yourself, well, I'm trying to find out what A is, so that needs rearranging. Again, videos in there. If you need to recap on how to rearrange, we'll end up with V squared minus U squared equals 2S. Okay, so let's go for it. V squared, 16.6. I'm going to pop some brackets around that. Sorry about these lines that keep appearing here, but we'll try and ignore them for now. Minus U squared. Now, it accelerates out of the pit lane. Everybody knows what happens in the pit lane. You come to a stop. So his velocity, his initial velocity, which we can actually add to that list, is 0, because his initial velocity is stationary, so it's 0. 0 squared, and again, just to keep this right. And we're going to divide that by 2 times the distance. Oops. And the distance that we've got is 2 times 100. So A is going to equal, again, I'll give you a moment, pop that in your calculator. Acceleration, and we'll do 3 significant figures here. Acceleration is equal to 1.38 meters per second per second. Okay. So that's my answer for this first bit. A equals 1.38 meters per second per second. Rightio. Next job, and I'll pop that in there, so I now know that value. Next job is to work out what the time taken is. So we can go back up to our suvat formulas. Now there's actually a few of these we could use now. Yeah, we could rearrange any of these formulas for T, because we've found out some of these unknown values. But the one I'm going to use here is just the top one. V equals U plus AT. Now the more experience you get of these, the more familiar, and you can actually use a couple of different versions. So I'm going to use this top one to calculate the time taken, and it's going to be v equals u plus at. I'm going to rearrange that for t, and again, if you need any revision on rearranging, go back and check out the videos on the playlist. V minus u divided by a. So I'm calculating what time is here. So t equals v, come over to my list, 16.6 minus u, which is 0. I'm going to divide that by a, which I calculated in the first part. So the time taken, 16.6, divided by 1.38. Time taken here, give you a sec to get on your calculator. And we'll do 3 significant figures again. We'll do 12.0 seconds. Okay, now I'm not a Formula 1 fan, so I don't actually know how long it takes to get out of the pit lane, but that sounds like quite a long time for me. But we're only playing around with some numbers here. Okay. So let's have a little look at the next one. We've got the same scenario, but the key word in this here is deceleration. Let's have a run through this. We'll run through this a little bit quicker. Same process, working on acceleration, calculating the time taken. Right, so here we go. Known values. What do we know? A racing car decelerates, so it's slowing down from 160 to 40. Okay, so its initial velocity is 160. So that's actually the letter U is 160 kilometers per hour. Alright. Final velocity. It slows down, so therefore the velocity is lower at the end than it was at the beginning. 60 kilometers an hour. 40 kilometers an hour, sorry. And we're going to divide these by 3.6. Again, check out those videos. So we've got U equals 160 divided by 3.6, and we'll have V is 40 divided by 3.6. V equals, I need to try and stop those lines. Right, so get your set, pop that in your calculator. So for our first one, 160, we've got 44.4. Next one, V, 40 divided by 3.6, we've got 1.1. Next bit, distance. Distance equals 270 meters. Okay, so we've got our initial and our final velocities. Well, best pop some units on them so we can get those. Now, apologies for those lines there, but let's see if we can rub them out actually. Oh, there we go. That was alright, wasn't it? Right, let's go for pen. Right, next bit. Back to these formulas, these suvat formulas. Now we're going to use the same formulas as before. So you go back and skip forward, skip back and forward as you need to. So this is the first one I'm going to use. V squared equals U squared plus 2AS. Rearranged for A is going to look like V squared minus U squared divided by 2S. So I'm going to apply these values. V is the 11.1. Oh man, that's annoying, isn't it? Minus U, 44.4. And don't forget those have got squares on the top. Let's get rid of that now. Come back there. And we're going to divide that by 2 times the distance. Now the distance we've got on our list here is 2 times 270. So A, I'll stick that in your calculator, see what you get. Okay, we'll do 3 significant figures. We'll notice here we've got a minus in the front. Now should we have a minus? Yeah, we should. Because we're decelerating, so we're losing velocity. So we've got a minus in front there. And that's what separates our acceleration, which is a positive, from our minus, which is a negative. So the acceleration is minus 3.42. Next bit, calculate the time. Same as before. Again, you could use a couple of different versions of these formulas, but we keep it nice and simple. So we've got V equals U plus AT. Oh man, I'm going to have to get that sorted out now. AT. We'll rearrange that for T is equal to V minus U divided by A. Going back to my list here, T equals V, which is our final velocity, which is 11.1, minus our initial velocity, which is 44.4, divided by, and I'm going to stick my minus in here, yeah, 3.42, because as you can see you've got a minus on the top, and this one will cancel out. We can't have a minus answer for our time, because time can't go backwards, can it? So if we put our minus in the bottom, we'll get a positive. So 11.1 minus 44.4 divided by minus 3.42. Like you stick that in your calculator. We'll do 3 significant figures, and we should get an answer of 9.74 seconds. There we are. So there's a fair bit going on, yeah. Now obviously you can skip back and forward to these examples, but what I'd like you to do now is I'd like you to have a little go at some of these questions on the next slide. Now you've got a copy of these in your workbook, and there's also some on the on Canvas, but if you can't access any of that, drop me a message and I'll try and help you as much as I possibly can. But feel free to go back onto there, see what happened, and if you've missed any of the previous videos, then some of this might be a little bit new to you, so make sure you go back to the beginning of the playlist, and then we can get you setting off on the right foot. So as always, if you need any help, let me know, but please make sure you do some practice. Once again, thanks for watching, all the best, bye.